financial duration numbers is actual percentage change so a 1% increase in the period rate is going to give you about 7% increase, and that's an approximation, a 7% decrease, I'm sorry, in the value of the bond. But this number is only for very small changes. So we will actually think about a 1 basis points, which is 0.01% change. Then this would mean divide financial duration by 100. Okay, but that duration is for a change in the period rate. So if YTM increases by 0.01%, then period rate increases by 0.01% divided by frequency. That means I need to multiply the financial duration by I need to further divide. Let me see. Yeah, I need to multiply it by oh, here they are. Okay. Oh, yeah, it was already doing that. Because that duration is number of periods multiplied with 0.01 times actually same interpretation. Think of that as if yield to maturity goes up by 1 basis points, value of the bond is going to drop by 0.00698%. And if you want to kind of test that, copy, that's the base. Let's make that 4.51. New value divided by the old value minus 1. As you can see, they are not the same because that financial duration number we have is for an extremely small change. But it's kind of a indicator. So approximately, if the interest rates changes by 1 basis points, value of the bond is gonna go down by 0.07% or 7 basis points, if you think about it, in terms of percentage change. If this was a 30-year bond, those things are gonna be much higher. Now, let me move this and copy into new sheet. Let's call this the only difference is, let me see, I'm not gonna worry about these coupon rates. We don't have to, but there is no face value. Actually, let's make this payments. Okay. And I'm gonna make this 12. I don't have to worry about this. Okay. Now let me get rid of these first. Where is my function? Payments, period rate, number of periods. Since this is a mortgage, there is no final payment, so it's 0. Okay. It says if you're gonna make $1,000 payments for the next 30 years and mortgage rate was 451, what you owe is actually 197,129. Okay. And average maturity of the payments 11.76 years, and that's the risk. If this was a 40 year, that was going to increase, or if it's a 15 year, and so on. For today, I'm going to stop here. Let's save this one. On Wednesday, we're going to look at two things. We're going to look at how to actually use that financial duration number and think about managing the risk of long-term portfolios like these using short-term instruments such as Eurodollar futures. And we're going to also talk about the concept of convexity. One thing about what you want to call duration, it is not a constant number. And let's think about, for example, if interest rates are here, that tangent is going to be a lot flatter. That means duration is going to be lower. Okay? And you can see that easily. If interest rates went up to 10, duration went down quite a bit. That means if you use short-term stuff to hedge the long-term exposure, as interest rate changes, that duration is not going to be enough to cover everything. it creates a problem called convexity. This is similar to the gamma exposure in options. If you do a delta hedging for options, as the price changes, delta changes. The change in the delta is called gamma. For fixed income stuff, we call that convexity. I haven't calculated here yet, but we're going to do it in a relatively succinct way. We're going to add it on Wednesday, and we're going to see what we can do to handle basically to do hedges that are both duration neutral and convexity neutral, which means we're going to introduce another sort of fixed income stuff because only long-term stuff have convexity. Short-term stuff don't. I'll see you guys on Wednesday.